The one-way speed of light is difficult to measure because it's impossible to define what the same time is in two different locations. To measure the speed of light in one direction, you need to know the start and finish times as measured on the same time scale. This could be done by using two synchronized clocks, one at the start and one at the finish, or by sending a signal instantaneously from the start to the finish. However, there is no known way to transmit information simultaneously. So enter my proposed device and facility, the Panoptimeter Kilometron. And that's for fun, but it's descriptive. And so it takes into account this issue. It addresses it with one proposed solution being something that I'm for now calling Pseudo-Simultaneous Synchronized Information Transmission. So Pseudo-Simultaneous Synchronized Information Transmission. Now the Panoptimeter is the device that has both a transmitter and receiver, but there are several of them. There are a total of 16 transmitters and 16 receivers. It could be as little as one and up to 32 total transmitters and receivers combined for the device. So it also takes into account the fact that relative motion affects the rate of clocks relative to the speed of light, which is an effect known as time dilation. So for example, if one clock is moved to the finish line, it will no longer be in sync with the clock at the start by the time it reaches the finish line. This is because moving clocks tick slower relative to stationary observers. Again, my proposed device and facility, the device again is the Panoptimeter, pan meaning all, opti for light, meter, so all light measurement, which really is just a nod to that it will solve the one-way velocity of light measurement problem. And Kilometron is the facility that would be built to house this device that is 1 kilometer in radius, or has a 1 kilometer radius. So the complications of the way to transmit information simultaneously is a problem, and the time dilation issue, those complications are the reason why so far the velocity of light has been an average of the speed for a round trip journey, or two-way speed. So as of now, it means that it is not certain that the speed is the same in both directions. So some experiments, such as timing how long it takes light to bounce off a mirror and return, leave open the possibility that light travels differently in different directions. And again, because of the way that the Panoptimeter Kilometron is designed, which has not been built yet, takes into account all of this information as well. There are various orientations, and it has moving parts which take into account for all of this. So again, so far, it is only possible to verify experimentally that the two-way speed of light, for example, from a source to a mirror and back again, is frame independent, because it's been said it is impossible to measure the one-way speed of light, for example, from a source to a detector, without some convention as to how that could be done. So it can be done, and this needs to be submitted in a way that there are parties that can fund the construction of the device. It's actually quite simple to do, I imagine. There could be some issues with my hypothesis about how to do this, but that can only be known once this proposal is met with a credulous source. And so, again, I have a solution for the instantaneous transmission problem, which is called Pseudo-Simultaneous Synchronized Information Transmission, as well as the time dilation problem of the motion that affects the rate of the clocks relative to the observer, a stationary observer, and also solving the two-way problem, which, interestingly enough, the velocity of light with this device will also be recorded simultaneously from two different directions. And there's a solution built in for the time dilation and the relative motion. So, in fact, there is quite simple, not necessarily easy, but a simple solution for the as of yet unmeasured single directional velocity of light. It might come as a surprise to some people to know that the one-way velocity of light has not been accurately measured, but this is actually, in fact, built into Einstein's equations in special relativity, where you are looking at the time that it takes to reach location. So from B minus, or you look at the time at B minus the time at A, and also it is equal to the time at A minus the time at B. It's a two-way velocity measurement. And again, so far as I can tell, it's been said that the one-way velocity of light cannot and has not been accurately measured. I think that this can be solved, and dare I say that I have the solution. So let's construct this and see if we can put this to rest once and for all. Measuring the one-way velocity of light with the device, the Panoptimeter, and the facility, the Kilometron.